the third day of this planned program. So today we'll have 3 lectures by Professor Michael in the morning, and then in the afternoon the coordinator, Professor Arvind, and then he will try to demo, and then after the demo of Arvind, we'll have a tutorial class by Professor Michael in the evening. So today we'll have 1 tutorial, 1 hour tutorial, and tomorrow 1 hour tutorial, so that we can able to finish the things which are discussed in the yesterday's and day before yesterday's. Right. So I'll start today's session with welcoming Professor Michael to give a talk on introduction on photocatalysis.
Focused on water splitting. Since I'm a physicist, not chemist, not working in, for example, in chemistry, I focus on physical foundation of such phenomena, especially on as similar like in previous lecture on adjusting materials properties to our demand, to our requirements, because it is important work. But from my point of view, for green energy, possibility divide or separate hydrogen and oxygen is very important from not only economic point of view, but also from climate and next dozen years in our future. For many years, people not strongly influence in your climate in Earth, but now when you see how much cars, how much pollution from industry destroying our Earth, it is important, because people thought that, for example, nuclear energy is also safety and green, because we not generate CO2. It is not good, because you should remember how working a system which utilizing nuclear energy. It is producing heat, and only small part of heat is exchanged or transformed in mechanical energy, and such mechanical energy also in the next step is transforming into electricity. Second problem is with transporting energy, because it's a different evaluation. 10–15% of energy exchanging into heat during transportation to end users. It is also great problem because it's difficult solve. Because, for example, anybody like when a nuclear station will be near his house. It is not good, but what is the great advantages of splitting water? And for example, like in India and some countries when it's a strong sun radiation. It is some strange situation, because for lifting we need energy when energy is forbidden because solar cell is not working because it's night. Second problem, it is very, very important in Europe. European community move huge money for supporting solar cells farm, and people grow big farm producing huge energy, but it's a problem with such energy. Because in day is very often difficult to consuming, but also is a problem for transporting or dispatch to another place. It is a problem with a flow inside electrical network. But what is it? When we have opportunity utilizing some solar energy which is not consuming into hydrogen, we can solve some problems, because we can use, for example, such energy we exchange for fuel to cars. And what is the pollution from burning hydrogen? It's water. It is any problem. And from such point of view, a topic is very important, but problem is also in details, because idea is very simple. As you well know, it is a special requirement for electrode material, and we can do it. But it is a problem with resistance, with efficiency, with some technical details. Because, as I told, idea is very simple, but application sometimes is difficult. I will divide my talk for a few milestones. It is at first I talked about principle and method of water splitting, and next I focus my interest on improving efficiency of such process, because all processes which we will discuss today and we discussed previously is not high efficiency processes, but we not be confused, because sun energy is free, and if we exchange some solar energy into electricity or into gases which we can use in future for exchange for mechanical energy, is very important. And here I would like focus on 4 topics, and band gap engineering, doping, semiconductor alloys, and nanostructure. From my point of view, when I focused on such topics, it is maybe join in one, because maybe last topic, it is nanostructure, is maybe quite different, because as Professor Azem explained on his talk, except opportunity to managing band gap of materials by utilizing a small element of bulk materials, which we know nanomaterials. It is maybe ultra-thin films. Recently, maybe 20 years or more, almost 30, we start a great interest in 2D materials. I show you a paper which is very simple from a fundamental point of view, because it's a paper regarding quantum chemistry calculation of a simple structure. But it was more than 2,000 citations, because it is connected with 2D materials for photocatalysis application. It is also some remarks from my long career regarding citation, number of papers, etc. You know that a person like Einstein was being refused from university very fastly because he not published sufficient number of papers every year. Yes, and also when you're working in very narrow branch, not popular but fundamental, people not citate you, because people interesting or working in the same subject is few. It was also my impression after collaboration with my colleague from India, not far away, from Vijayawada, when I start collaborate with him with luminescence of glasses. It was enormous increasing of citation, but Professor Variach told me in India we have more than 2,000 persons which are members of Indian Luminescence Society. But for example, when you're working in black holes or another topics, it is a great difference. And also, you don't afraid when you put application for a PhD or postdoc position, because sometimes, many times or mostly, people looking for person which able to do something. It is expert, for example, for thin films grow, crystal grow, sophistical measurements. It is also very important in doing science and in your career. But we back to and photocatalysis may be used not only for water splitting, but also for cleaning water. I told most generally, cleaning water, because we have some pollution in water, especially it is agricultural industry origin, because I told what agriculture, because when you cultivate in small area, you not use special chemicals, but such chemicals also, like today after strong rain, move to source of drinking water. And from such a point of view, it is a very interesting topic, and I think is crucial because we can use we can use a free energy, because energy up to now in our European community is not connected with a task. For example, when we buy gasoline, it is 60% of price is task. But I am afraid when start put some task for electricity from sun. Okay, and what is a picture? It is, you can buy such, it is a probably Nissan or Hyundai, I don't know what is a trade make. It is a car for liquid, for hydrogen, not liquid, because hydrogen is difficult to be liquid. Hydrogen. And for example, in Poland we have two fuel stations only. It is a problem for future. How will be solved? But I think that from economic point of view, when will be problem with conventional energy, such car will be popular. But here is a problem with storage hydrogen. You can also thinking about such topic, because most of you working in nanomaterials, on porous materials, and it is a possible topic for application for hydrogen storage, because as you see, we have a few problems to solve for application. You know that in opposite to gasoline even or diesel, we have a problem with very dangerous fuel, because they need anything to be exchanged from nice eco-friendly fuel into a bomb. And such a problem of utilizing light to splitting water is not young. We have a very long tradition for discussion about such possibilities. But from such point of view, problem from chemical point of view is quite simple. We should add to molecule of water some energy. It is a Gibbs energy, which is not so big. It is equivalent 1.23 electronvolts to utilizing light, divide hydrogen, water for hydrogen and oxygen. And what is requirements to such a photoelectrode? Is active element which help nature to divide water. Special band gap, but it is from one point of view. Low electrical resistance. It is a problem because a semiconductor not usually have a small electrical resistance. Most important, good corrosion corrosion resistance. It is a great problem which arises in many applications of materials. We have very good materials for particular application, but it's a problem that may be very fastly destroyed. It is also like you maybe part of your working in biomaterials for medical application, when we have excellent materials, excellent properties, but after abandoned to human body, which we tested utilizing, for example, body simulated fluids, such materials very often at first interact with such environment and also may be destroyed. It is a little bit problem except fundamental problems. High photon conversion efficiency. It is necessary to generate a pair electron hole. What is it? Fast charge transfer with electrolyte. It is also important. And last, durability. And next will be question, because mostly in science we not discuss, but when we like make commercialization of our idea, a great problem arises with cost of manufacture. It is also crucial, because we not need small devices, but we need big or great devices for industry processes. It is also great problem for such producing element. And also should we remember about future, it is low cost and easy for maintenance, because some equipment may be not so expensive, but maintenance it will be expensive. It is a problem, because such maintenance should be, for example, performed frequent exchange, and also when we produce such devices, we also should remember about it. And for example, I told from different point of view, when you should exchange element for $200 expensive in Audi car, you should remove engine, because engineering forget about lower expenses of maintenance, and it is necessary to 15 times more pay for simple work. And also I would like show information about a place when you can apply for postdoc, for PhD. It is a leading institution in our country. It is Institute of Physics, Polish Academy of Science, and my colleague and collaborator, Professor Suchocki, for a long time working in water splitting. he is also expert of luminescence properties. He working in chalcogenide and halide materials, perovskite, double perovskite for different application. And from such point of view, it is a good place for continue your scientific career on initial stage. It is very good. They have a very good laboratory in which grow single crystals, and for different application. Mostly they grow crystals for optoelectronic application, but when they understand that crystals for luminescence properties may be also useful for application in water splitting, they start working in such topics. And they grow very good photoelectrode based on zinc oxide, and after some experimental tests, because they perform several tests for water splitting, they try to modify such materials, and they perform standard measurements, because we can, utilizing our standard laboratory equipment, to describe properties of materials which possess multi-purposal application. And for example, when you see as grown zinc oxide possesses absorption region up to 475 nanometers. But doping enhancing such area, but it is from luminescence point of view, it is very simple and natural process. As I will be very often recall you information how you can, utilizing your own skills, own possibilities, to application and different, to working in different but very similar from technical point of view problem. And it was very simple, but strongly increase efficiency of materials, because as you remember from yesterday lecture, that in such visible spectral range and in UV, energy of sun is most important. But it was some little bit problem with such electrodes, because erosion processes arise. And good material, very simple, well-established technology of preparation, but some problems with durability. Because as you see here, it is after 10 hours of illumination. 10 hours is not so big time when we need equipment for such measurements. And now we can discuss about two possible way of water splitting. And one is a traditional configuration when we have a solid electrodes, and second, when we have nanoparticles which absorbing sun radiation may be divide or splitting water utilizing a free step, because such free step are as follow. After interaction sunlight with electrode is a generation of electron-hole pair after absorption. It is a typical process. Next is a charge separation and migration to the catalyst surface. It is also a problem when such prepared electrode material should have such opportunity to migration pair hole electron to surface of active media electrode. And next is reduction water by electrons and generate hydrogen on a surface of catalyst. It is very interesting and simple process, and from physical point of view is here not exists any problem. It is very simple, well known from first look processes, and is important how fulfill such requirements which we told, which we discussed earlier regarding efficiency of process, durability of materials, and also with expenses, cost of preparation and maintenance. And what is this important question and important problem in such? It is right here. To achieve maximal efficiency, we should have not only well described band gap, but also a position of band gap. And also, as we discussed earlier, should absorbing most of sun energy. It is important from spectral point of view. And here is some groups of materials which are responsible for possible application. As you should remember that I give you such presentation, and also with a list of link to review and special topics manuscript where such problems are explained in detail. We have except yesterday and Monday discussion, we have one group so-called nitrides. It is when I was in your age, it was also important utilizing nitrides for generation laser beam in ultraviolet. It was a so-called blue laser. And here we have a big spectrum, and people which working in oxide materials, which working in chalcogenide materials, also maybe should a concurrence of nitrides. And also is important to adjust band gap and position band gap to requirements water splitting. And next I will be present some methods what is solved problem of not only band gap but also adjusting position band gap, and third problem is connected with efficiency of such process. And we have some way ordinary band engineering. We discuss about many methods in tutorial. I explain also another method for band gap tuning utilizing so-called intermolecular pressure. But we can do it like we discussed yesterday. We can perform, for example, investigation regarding influence of materials composition. It is one of problem I show you taking account chalcogenide materials, very useful for tuning band gap. Also, we can utilizing Maser phenomena is a so-called doping. But doping, I think here for generating so-called acceptor and donor levels, because depending of valency of oxidation level of doped ion, we have opportunity to generate inside band gap additional levels which give us opportunity to adjusting band gap. And next, maybe here is in left cation doping, and here anion doping semiconductor. And we have adjusting band gap for our needs. Next, we can do it so-called solid solution. We discussed yesterday in detail about it. We can also have opportunity to make a process of generating pair Hall electron utilizing a two-step process in annealing or making alloys of two semiconductor. We also have a next opportunity. It is connected with a special construction. We can put some active elements on surface of semiconductor, also to adjusting band gap and improving efficiency of generation pair electron hole. But during my previous lecture, I told that we many times should or have opportunity to predict some materials properties. Utilizing a modeling of materials. We can have opportunity adopt some software to perform a calculation. It is well recognized method for performing calculation, and now if you like publish paper in good journal, accept good measurements, is necessary to include a part connected with explain observed phenomena in microscopic level. And quantum chemistry calculation are a very useful tool for such. But now we have many programs. Some of them is free for science, some is very cheap for science, some is quite expensive, but when compare expenses in commercial application, for example, for drug companies or pharmaceutical companies, it is price is very low. And what is it? And some time ago was a published article. Authors perform some quantum chemistry calculation regarding describing properties, electronic properties of 2D materials. Here it is a cation, molybdenum and vanadium, and here in right side three brothers, sulfur, selene and tellurium. And it was surprised for them that such materials may be very useful for application to water splitting, though exceptional properties. Because you know that graphene is a perfect two-dimension material. Double layers of such material not have same properties. It's quite different. But authors try to performing a quantum chemistry calculation for different structure. 1 layer, 2 layer, 3, 4, 5, 6, and compare electronic properties of such heterostructure. Because from a practical point of view, it is very difficult to deposit 1 layer of material. It is difficult, and discovery of graphene confirm it. When we like deposit layer, 1 layer crystals, it is necessary to preparing a perfect substrate. and also method of deposition one layer is not so much, but as such which will be useful are very expensive. But we can go to interesting results because it is important how we can modify materials. In the right side we have energy and top of valence band and bottom of conducting band for 1 layer, 2 layer, 3, 4, 5 layers. As such, publication is also open access, and it was a surprise that how changing a band gap of such two or almost to the structure, because band gap of molybdenum sulfide change from 0.9 up to 1.6 when I well remember. But it is very interesting results, but we can expect because we go from bulk material to nanoscience, to nano. And it was improving or put some properties of such materials do deposition thin films all heterostructure, because when we have one layer we talked about 2D material. When we have few layers we speak about heterostructure. But such properties is very amazing. It is also very important information how band gap may be modified taking account only one parameter like thin film thickness. And it started a huge number of theoretical investigation. As I told, such paper published in no so prestigious journal have almost 2,000 citations. And it was era, I think 1 or 2 years, when 50% our manuscript submitted to optical materials were connected with theoretical calculation of heterostructures 2D, but such diselenite material. Yes, or the chalcogenide, because it is also utilizing not only sulfur, which was first most important, but also tellurium and selenium. Such free chalcogenide materials do different behavior, as I recall, I yesterday told, because the sulfur is fully dielectric, selenium is more metallic, but semi-metallic is tellurium. It is, and about such materials is not end of story for today, because in next lecture I also will discuss or take account of such materials. And such information, which was noticed by people working in photocatalysis, start a new era with preparing composite materials, because such two-layer structure were combined with quantum dots, with nanoparticles, and also more complicated structure to achieve better desired properties for water splitting. And now also a few examples how we can utilizing material engineering to improve efficiency of catalysis. Here is an example of interesting application or interesting proposal, because it is most of proposal for solving process searching efficient photocatalyst materials. It is a multifold water splitting when interaction of pair hole and electron have a two-step process. And also is next application. It is so-called heterojunction, when is nanoparticles connected with quasi 2D materials for improving properties connected with efficient photocatalysis. It's a few opportunities. Also, is important so-called carbon nitride. It is a material which metal-free. It is environmental safe. It is very good material. Such crystal possess many polymorphic behavior. But it is also very easy to modify such materials by doping. It is important because such fully non-metallic materials, it is sometimes a great problem, and you probably not participate in a hot topic few 20 years ago, maybe more, when was discovered a special crystal structure of carbon. It is, for example, fullerenes. Fullerenes possess some interesting properties, but doped fullerenes, for example, possess superconductivity properties, and also some catalytic properties with nanorods, etc. It is interesting because here is example. It is information how doping may be improving absorption efficiency for such doped materials. It is also quasi two-dimension material. And here is also example of a special kind composite, when we have a sheet of carbon nitrides with famous material for electrode. It is titanium oxide. As such, heterostructure possesses very good photocatalytic properties, and here you're able to see how enhancing, how grow efficiency for water splitting application. It is maybe 10 times. It is amazing when we have two materials, and after make composite materials, we significantly improve interested as decided property. And also next example of solution composition for battery for photocatalysis, when here was application of also wolframium oxide and carbon nitrides, and such a two-step process is under consideration. It is tested, but it will be also promising for future application. Next, we have so-called MIOIFI. It is metal organic frameworks. It is also interesting direction for searching better materials for water splitting, because what is importance for porous materials? It has like nanomaterials have a grid active surface. Yes, because when we have some nanorods, we have some pores, it is surface of interaction with water significantly enhanced. And you're able to see how methods, how knowledge, how idea moving from one application to second, because yesterday when we discussed about improving solar cells materials, one of direction very promising is materials which organico-metallic structure exist and are very sometimes very cheap, but it is also interesting from future when we should after application, for example, start the process utilization. When I sometimes driving and see some hectares of solar cells, silica solar cells, I thinking how will be expensive a process, for example, utilization after 10-15 years. You know, it is maybe great problem. When you probably you not remember era when was monitors with bubble utilizing X-ray as a source of excitation. It was a situation that full process for example, for destroying such equipment, for utilization equipment, but not like people thought that we're melting and removing anyway. It was expenses over cost of production. It was and with silica maybe also a problem. And also is some proposal for solving process of improving or finding efficient photocatalysis electrode is heterostructure or application of such. And here I don't know, I'm afraid it will be visible. Here is information regarding efficiency of a particular solution. And we see how different is efficiency of some materials, but here is not information regarding durability of such, because when we buy shoes for 100 rupees and we use one day, it is sometimes difficult to tell it is expensive or cheap, because when we buy for 400 and we work in 1 month, it is cheaper, but from first aspect expenses is higher. It is also important, but some of proposed solution give promising information for future, but is still working, especially more sophisticated structure. And here is also information about very old and simple in organic elements for water splitting, and we may be told about so-called titanium-based photocatalysis electrode, tantalum niobate-based photocatalysis, and metal nitrides and oxynitrides. It is also interesting that managing chemical composition, or as you see here, preparing more complicated composition, we can improve properties. But in next talk, I also will focus it on such topic connected with so-called high entropy materials, because enhancing of configuration entropy sometimes is a good direction for improving properties of such devices. And here is a comparison of efficiency, different attempts for water splitting, and also is a typical methodology, because we have a core material and changing one of ingredient, one element of composition. It is a typical way for application, for searching new materials, but in such we can find optimum chemical composition. And also, except very expensive and consuming money and time measurement and synthesis process, because you know that not each attempt will be successful. Sometimes we must change many parameters. It's like, for example, like in crystal grow, when we put very expensive ingredients, but a temperature or some another parameters like a speed of moving particular elements not give good results, and we lost expensive materials. But here, do a very sophisticated software for calculation bands gap, because for when we take account for calculation inorganic materials, we use another tools when we try to calculate properties of big molecules. And here is also a proposal application of carbon nitrides connected with nanoparticles of titanium oxide for water splitting. It is also possible we can, for example, utilizing such we have some information about road of our work, experimental work, and it's probably interesting solution, but I hope many people, maybe in India or China, apply such prediction to obtain a good equipment for water catalysis. And I also try to believe that prediction of theory fulfill, because I have some topological materials and try to confirm or check it such materials possess such properties. It is very expensive and consuming much time, but it is sometimes necessary to put a risk. Here is my opinion about future of water splitting, because after check or after read some literature, some discussion, if is agreed that process is not efficient. from away. Should lost energy, we apply for application producing hydrogen and oxygen. Here is some topics would be that are necessary to open such to have efficiency of splitting process, and I will be break of a situation. Maybe some theoreticians involved in process to understand from microscopical view to understand such idea and make better materials properties, give us in future significant improving such low efficiency of water splitting utilizing free energy. Thank you for your attention here, and I hope we have a small break now and start next lecture. It will be